Okay, what I'm going to show you how to do here is to find the centroid of a triangle with respect to the equations of the medians. So there's a really easy way to figure out what that centroid is, and then there's a more complicated way. Of course, I'm going to show you the more complicated way, and then at the end of the video I'll show you the quite simple way. Both ways is to find the coordinate of where these medians intersect, which is at one point in that triangle. So here's an example here. Find the coordinates of the centroid. We'll call that point C of the triangle PQR, where the vertices or the corners of the triangle are stated right here. Now I have a set of axes over here, and we'll just sketch where these points are over here, just so we get an idea of what the triangle will look like. And mine's not going to be to scale, it's just going to be rough. So let's take a look at that. Okay, so here's what my triangle looks like. Now you don't have to graph this problem in order to solve it, but just gives us an idea. So where do we start? What we're going to do is find the midpoint of the sides. Now since medians start at a vertex and end at a midpoint, we're obviously going to want to find the midpoint of each side. Now before I get started, I have this. I have a formula sheet of coordinate geometry formulas that we're going to need for this problem. And for this problem, we're going to be using gradient, we'll be using midpoint formula, we'll be using equation of a line, and I keep this handy because I'm going to be using it. So, to get midpoint, this is the one I'm going to use. The mean average of the x-coordinates and the mean average of the y-coordinates for a line segment. Midpoint of PQ, I'm just going to give it a name. I'm going to give it a letter for a point, and I call it T. You can call it anything you want. So where I get these, those are the two x-coordinates. Messed up. Let's try that again. Here are the two x-coordinates for PQ, and here are the two y-coordinates. Royally messing up here. The midpoint of PQ, which I'll call T, give me this coordinates right here. And let's try this again. Here are the two x-coordinates for P and Q, right there. And here are the two y-coordinates for P and Q, right there. So after many mistakes, that's my midpoint. Find the gradient of RT. And RT, if this is the midpoint right here, which is that point right there, I want to find the gradient of that line. Now that's going to be the median, and in order to do this problem, what I'm doing is I'm working out the equations of the medians to find the centroid. So to find the equation of the line, I need two things. I need a point on that line, I already have that, and I need its gradient. So to get the gradient is always change in y over change in x. So I'm going to do that with these two coordinates right here, r and t. And I've got the r coordinate here and the t coordinate there. So let's find the gradient right now and see what we get. Doing change in y over change in x, I get the gradient of this median right here is -1. So these are the two things I need to write an equation for this line, and that's my third step, is to write the equation of that median. And where I'm going to start is, I always start with the equation of a line in point gradient form, where these two represent a coordinate on the line, and that represents the gradient right here. Okay, so let's do that one and see what we get. Gradient is -1. The point I used was r, -6,9. So when I subtract that -6, it turns positive, and y -9 is that y coordinate right there. So now what I'll do is I'm going to get it in gradient intercept form, which means I'll expand that -1 through, or distribute, and I'm going to rearrange this equation a little bit. So when I expand that -1 through, I get -x minus 6. Now the form of the equation I want it right now is I'm just going to get it to y by itself, because that's the easiest thing to do at the moment. And in order to do that, I'm going to take that -9 and add it to the other side. So my equation of this median right here is y equals -x plus 3. Figured out. What I've figured out here is the equation of this line RT, which is the first median of this triangle. Now I'm going to do these same steps again, finding the midpoint of a line, finding the gradient, writing the equation, and I'm going to work out what their point of intersection is. And that's kind of the hard part. So, where do we go? The next line segment I'm going to figure out the midpoint is a PR. I'm going to find the midpoint of this, and I'm going to do this all over again. So let's find the midpoint of this segment, and we'll go from there. Midpoint of PR, I'm going to give that a letter too. I'm just going to call it S. And for the coordinates, this time I didn't mess up. I'm using these coordinates right here. -5 and -6 are the X, and 4 and 9 are the Y. Okay. So let's get the midpoint there. All right. How does that look? And I'll put it on my triangle just to make it look good. Okay. Okay. So far, there are my two medians. I drew it really small, but that's okay. Now, the next thing I do, just like I did here, is I'm going to find the gradient of QS. I'm going to find the gradient of that line, and then next I'll find the equation of it. So, gradient. Here we go. The coordinates I use to find the gradient of QS are, of course, S and Q, and I've got the change in Y coordinates over the change in X coordinates. And I get a gradient of -1/5. And that does make sense because that is a negative gradient slightly going down. Now, what's next? Got to find the equation, not of RT, but of QS. So let's get that going on. Start with my general formula of equation of a line that I use on my formula sheet. And I plug in my values that I've figured out. I've got my gradient right here, and I can use either the midpoint S, or I can use Q. And I think I'll use Q for my equation of a line just because it has no decimals. Messed up again here. So my gradient is -1/5, and the coordinate I'm using is 2, 5, and so that's a -5 and that's a -2. Now what I'm going to do is I'm going to rearrange this equation to get it in gradient intercept form like this. So same thing I do is I'm going to distribute this -1/5 through, and then take that -5 and add it to the other side. And that's what I get when I distribute the -1/5 through. Now I'll take that 5 and add it to the other side. Okay, so this equation has a bit more fractions than my previous one. That has no fractions, but that's okay. Now here comes the fun part. I've got two equations for the median. The equation of one median is this one right here, and the equation of the other median is this one right here. Now, the key is this. The point of intersections of those two lines is the solution of these two simultaneous equations, and that is the centroid. So notice I only did two medians here. I did these two medians right here, and I don't need the third one because the point of intersection is already there. That's the centroid, and I need its coordinates. And in order to find its coordinates, I solve for this system of equations, 1 and 2. Now, one way to solve it is with the graphics calculator. I can put both of these equations in, I can graph them, and I can find their point of intersection, and that is my centroid. But where's the fun in that? And let's just say we've got this going on. So let's use some algebra. Now here's what I'm going to do. Since these two equations are both set to y, I'm going to set these two expressions equal to each other because they both equal y. So you set these both equal to each other, and we're going to solve for x. Okay, done. Now what I do is I solve for x. One way to solve for x is this x term here and this constant term here, I'm just going to swap sides, and when I do that, they have to change their sign. I want to get all the x terms on the left, and I want to get all the constant terms on the right. So when I swap these two, I get this. Now, I collect like terms over here, and I collect like terms over here. Negative x plus 1/5 x. Don't forget there's a coefficient of negative 1 here. So what I'm really saying is negative 1 plus 1/5. That gives me negative 4/5. Negative 3 plus 5 2/5 gives me 2 2/5. Now, to solve for x, I have one last step, and that's take the constant term and divide it by this coefficient. Okay, so I've solved for the x-coordinate of the centroid. X is negative 3. So that coordinate right there has an x value of negative 3. Now how do I solve for the y? Well, with simultaneous equations, what you do is once you get the solution to 1, you substitute it into another equation to solve for y. You can pick any equation you want. You can pick y equals negative x plus 3, or this one right here. Now, which one would you pick? I picked this one, because it has no fractions. So we take that x equals negative 3, and we substitute it into that expression here to get the value of y. And then we're almost finished. I get a y value of 6. The x value is negative 3. And don't forget, when I substituted that negative 3 in there, the equation is negative x. So that is saying negative x. Negative 3, I mean, plus 3 to give me 6. So the coordinates for my centroid, 3, 6. A lot of work. That was a lot of work. We had to find the equations of two lines. We had to solve the simultaneous equations to find the coordinate of the centroid. We had to do gradients. We had to do all sorts of things to get that point right there. Now remember I said there was a much easier way to do that. And we can do that. Now the centroid of a triangle can also be found by finding the mean average of the x-coordinates and finding the mean average of the y-coordinates. Will that work for our example? Will that work for these coordinates right here? Well, let's try it. Here's the x-coordinates, negative 5, 2, and negative 6. Here are the y-coordinates, 4, 5, 9. We take the mean average of both, and we get the same value that we did with all of this work. So, you choose which method you want to use. It's up to you. See you next time.